Hey everyone! Today, we're going to explore a cool piece of code that helps us ensure our React applications are running smoothly. You see, as developers, it's crucial for us to test our code thoroughly to catch any bugs or errors before they reach our users. And that's where our code comes in handy. In this snippet, we've crafted a series of tests using the Chai testing library for a React component. These tests help us check various aspects of our component's behavior, like rendering, state changes, and interactions with child components. By running these tests, we can gain confidence that our component is functioning as expected and delivering a seamless user experience. Now let's dive into the code and see how it all works. The first line of code imports the necessary dependencies for our testing setup. Here, we're importing the expect assertion style from the Chai framework. Chai is a powerful assertion library that provides various assertion styles to make our tests more readable and expressive. Next, we import the shallow function from the enzyme library. Enzyme is a testing utility for React that allows us to render React components in isolation, making it easier to test their behavior. Moving on, we import our React component that we want to test. This component could be any React component from our application that we want to ensure is functioning correctly. Now, we define a test suite using the describe function provided by Mocha, a JavaScript test framework. This test suite serves as a container for organizing our individual tests related to the myComponent React component. Within the test suite, we define individual tests using the IT function provided by Mocha. Each test represents a specific aspect of the myComponent that we want to verify. Inside each test, we use a try-catch block to catch any errors that might occur during the execution of the test. This is important because it ensures that our tests don't fail abruptly due to unforeseen errors, and it allows us to provide meaningful error messages. We then use Enzyme's shallow function to render an instance of the myComponent without deeply rendering its child components. This shallow rendering approach helps us isolate the behavior of myComponent for testing purposes. Within each test, we perform assertions using Chai's expect function to verify the expected behavior of the myComponent. These assertions could include checking if certain elements are rendered, if state changes occur correctly, or if event handlers are triggered as expected. Finally, we run our tests using the Mocha run function. This executes all the tests defined within our test suite and provides us with the test results, including information about any passed or failed tests. Overall, this code tutorial demonstrates how to write effective unit tests for React components using the Mocha test framework, Chai assertion library, and enzyme testing utility. By following this approach, developers can ensure the reliability and correctness of their React applications. In conclusion, the code we've explored today serves as a foundational piece for ensuring the reliability and functionality of React applications, particularly in terms of unit testing. By employing frameworks like Mocha, Chai, and Enzyme, developers can create robust test suites that verify the behavior of their React components under various conditions. One of the key benefits of this approach is its extensibility and reusability. The modular nature of unit tests allows developers to easily add new tests as their application grows, ensuring that new features integrate seamlessly without breaking existing functionality. Additionally, these tests can be reused across different parts of the application, saving time and effort in the long run. Moreover, this testing setup promotes efficiency by catching bugs early in the development process. By identifying and addressing issues before they reach production, developers can minimize the risk of unexpected errors and maintain a high level of code quality. From a development principles perspective, this code incorporates several best practices commonly associated with JavaScript technologies. It emphasizes the importance of test-driven development, TDD, where tests are written before the actual implementation, promoting a more structured and predictable development workflow. Additionally, it encourages the use of modern JavaScript tooling and libraries, showcasing how different technologies can be seamlessly integrated to create a robust testing environment. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video helpful, please like and subscribe for more of the same. Thanks again, and remember, we're always learning, so keep coding and keep exploring.